Okay, Algebra 2, I've promised to try to make this a quick video lesson. Remember, first of all, we've gone through this same lesson in class a bit. Also, remember that on my website I've linked to some video lessons from some other teachers who also cover this topic of how to solve radical equations. So, like I said in class, if my explanation that I'm giving in this video lesson doesn't make sense to you or you still have questions, by all means, check out the video lessons from some other teachers and see if that helps. The first point to make, I think this is the very first paragraph in the textbook, at least it's the first that I've copied here. This sentence is very important. If you're going to try to solve a radical equation, and up until now we've been talking about how to simplify radical expressions. They weren't equations, they weren't set equal to anything. But once you want to solve and figure out what x is, first thing you got to do is raise both sides of the equation to a power that's going to get rid of any radical sign or any rational exponent that you have. So I'm not sure that this generic explanation here is going to help you a whole lot, but that's one way of looking at it. An example might be more useful, so let's get rid of this, and let's remove this out of the way here. Okay, so actually, why don't I delete that and have this thing slowly build for you. If you were given that problem, cube root of x minus 4 equals 0. Well, the first thing you're going to want to do is remember that you're going to unpeel this problem in the opposite order of PEMDAS, dealing with addition and subtraction, undoing those, in other words, first. So I'm going to move that 4 over. So now I've got cube root of x is equal to 4. Now this gets to the point, the next step gets to this point that I've highlighted in yellow here. To get rid of this cube root here, you've got to raise it to the third power. The third power and the third root undo each other. So that's what we do to both sides. You got to do it to both sides since it's an equation, otherwise it won't stay in balance. The left side now becomes x. The root 3 and the power of 3 cancel each other out and you're just left with x on the left side. The right side is 4 cubed, and you should know that 4 cubed is 64. So x, the answer here is x is 64. Let's look at another example here, a little more complicated. Or at least coming at it from a different angle. This time you've got some multiplication to undo. And again, just like before, undoing in the opposite order of PEMDAS, get rid of the 2 first before you worry about getting rid of this rational exponent. So divide both sides by 2. And that's how you end up with x to the 3 halves equals 125. Now, to get rid of this 3 halves, this time we're talking about a rational exponent instead of a radical sign, but it's the same principle. To get rid of that rational exponent, multiply by its inverse, 2/3, an exponent of 2/3. But you have to do that to both sides. The left side, the 3 halves and the 2/3 multiplied here, cancel each other out, and you're left with x to the first power. On the right side, you're now taking the cube root of 125 and then squaring it. That's what to the 2/3 power means. You should know by now the cube root of 125 is 5, and so 5 squared is 25. You can always plug this in to check. Plug 25 in for x here, and you'll find this does work. I strongly recommend that you do get the habit in chapter 7.6 of checking the results that you get, because you're going to get a lot of results. In tonight's homework maybe, but certainly as we go forward, where you're going to get an answer that doesn't actually work. We're going to call those extraneous solutions. You'll see that in a minute. So before I get to that though, here's question 9. Hit the pause button. When you come back, I'm going to show you the solution to number 9, but I want you to work it out first. Okay, I'm going to assume that you did that, and here's the worked out solution for number 9. The answer is 5 over 3. If you didn't get 5 over 3 or you have any questions about it, hit the pause button and look through the steps that I've taken here. Come into class with those questions. I'll be happy to go over those with you. Okay, I'm going to move on here. I'm going to assume that you did pause if you needed to. Next example straight out of the textbook is example 3. Very similar, but this time it's a radical sign instead of a rational exponent. Like I said before, the first thing to do is to move that 2 over. Now I've got a radical sign, or in other words, a square root sign. To undo a square root, you square. So you've got to square both sides. The left side The radical is canceled by the squared symbol there. So now I've got 4x to the minus 4x minus 7 rather on the left, and 3 squared is 9. From here, this is a simple Algebra 1 problem, and you should be able to solve for x and find that x is 4. The issue, though, is to find out whether or not it's really 4. And the way to check, like I'd said before, is to plug 4 back in for x. Here's the original problem. That's exactly what the textbook has done here. They've plugged in 4 for x. They work it out and find out, sure enough, 3 is equal to 3. It does check out. Okay, similar question, number 18. Hit the pause button. When you come back, I'll show you the answer. All right, I'm going to assume that you did that. There's the worked out solution, x equals 3 halves. It's not highlighted in yellow this time, I made a mistake, but it is 3 halves or 1.5. Again, hit the pause button and look through the steps. If you have any questions, come into class with those questions. I'm going to assume that you've paused and looked the answer over and that you're fine with it, or that you're going to come to me with any questions you have. I'm going to move on to the next slide. Here we talk about a paragraph taken straight from the textbook because I want to emphasize this idea that you can get an extraneous solution. The most classic example, the simplest example where you might get that, imagine you were given the question or asked to solve for x when the square root of x is equal to -1. Well, it's a square root, so you're going to square both sides. So the left side would become x. The right side would be -1 squared, which is +1. And so what you're ending up saying is that +1 is equal to -1. That's not true. And whenever you get a result that's not true, that doesn't check out, what you have is an extraneous solution. And you'll get those. I'll talk about this in class if you haven't heard enough about it already, and ask me about it if you're not sure about it. It's important that you check your work. So the example out of the textbook here, let's build this a bit, promises this will be an extraneous solution. Well, what are we going to do here? I've got x's on both sides. And one of them is inside a radical sign. The only way to get rid of that radical is to square that side, which means I've got to square both sides. The left side, x minus 4, now the whole thing is squared. The right side, the radical is squared. So the right side's just going to become 2x. But the left side is x minus 4 times x minus 4. I've got to FOIL that, and that's why they come up with this quadratic. Well, it's set equal to 2x. I'm going to combine the like terms, and it's going to become minus 10x, and the right side's going to be 0. Now I've got something I can solve. This is a quadratic you should be able to see how to factor. The factors of 16 that add up to make -10 are -8 and -2. That means x ought to be either 2 or 8. But if you plug these back in, you'll find that only one of these two works. Try plugging in 2. 2 minus 4 is -2. But 2 times 2 is 4. The square root of 4 is 2. 2 is not equal to -2. This gives you an extraneous answer. You'll find that x equals 8 does work. Okay, once again, here's a problem. Do 24 here. Hit the pause button. When you come back, I'm going to show you the answer to 24. All right, I'm going to assume that you've done 24. And here it is worked out. You'll actually get two different answers, 3 and -1. Notice we did exactly what was done on the previous slide. We had to square both sides. The left side simply became 12x plus 13. In other words, the radical sign went away. But the right side became a set of binomials that we had to FOIL. So we ended up with this quadratic, and we had to move 12x plus 13 together with this quadratic to get 0 equals. And this quadratic we were able to factor, and factor it down to 4x minus 12 times x plus 1. That gave us two different answers for x. Only one of those, though, if you plug it back in, works. Only 3 will work. You can always check your work, I talked about this also in class, by putting it into the graphing calculator. Instead of, and let's go back to the previous example, I was given y equals the square root of 12x plus 13, I'm sorry, the square root of 12x plus 13 is equal to 2x plus 1. But I can make it two separate equations. I can make it y equals this thing, And by the way, if you don't know how to plug this in, try plugging it in as parentheses around it, 12x plus 13 raised to the 1/2 power. The right side would be y equals 2x plus 1. So this will be y1 in your calculator, and this will be y2. You'll have two different equations. If you put those into your calculator and graph it, you'll find that those two lines only cross in one place. They cross at 3. Likewise here, x minus 4 and square root of 2x, if you put both of those equations into your calculator, you'll find they only cross at one place, right here where x is 8. And so I think you'll find that the graphing calculator can help you to double check your work. Come into class if you're not sure how to do this. I did show a bit of how to do this in A block today, but didn't have time to show it in C block, so I'm more than happy to talk this through and wouldn't be surprised if I have to. I just thought it might help you out a little bit. Your homework tonight is just 3 problems if you have C block, because C block's class was shortened today. So C block will do 5 and 14 and 23. Bring those into class and we'll go over the answers to them. That's it for the video lesson.